Hi students, in this class I am teaching to you the important weightage for all competitive exams. The lesson name is Dual Nature of Radiation and Matter. Dual nature of radiation and matter. Okay, so now at first, this dual nature of radiation, matter, atoms and nuclei, all these lessons are treated as modern physics. Modern physics. So in this, the main important role plays by Planck's quantum theory. So what is the Planck's quantum theory and which one is taken for the implementation of dual nature of radiation and matter, atoms as well as nuclei? At first, the basic concept in dual nature of radiation matter is the radiation. The first word is nothing but radiation. The radiation is considered as every radiation consisting of a small particle, nothing but small particles, and those particles naming as photons. Okay, so now here, what is the photon? Photon is nothing but very small particle, and this small particle consisting of energy. How the energy consisting by the photons? The energy consisting by the photons in the energy packets. Now what is the name of that energy packet? That is quanta. Okay, and that's why this theory is called quantum theory. Proposed by the scientist Planck. Okay, now I'm taking the next one, and in this, the energy of the photon E is directly proportional to the frequency of radiation. Energy of the photon is directly proportional to the frequency of radiation. Here E represents the energy and nu represents the frequency. E represents energy and nu represents the frequency. Okay, and now it means once one quantity is proportional, then immediately we are taking it as E is equal to, remove the proportionality and keep a constant. That is H nu. Now H is equal to Planck's constant and its value is 6.63 into 10 power minus 34 joule second. 6.63 into 10 power minus 34 joule second. Okay, and in the problem this value they used to give in the brackets. Okay, so within the problem itself, if this value can be utilized, then that value should present by the problem. Don't worry about that. Otherwise you can easily remember, and this constant as 6.63 into 10 power minus 34. Okay, now Here I am taking further next one. In this energy of the photon, we are taking another way. E is equal to h nu, and as you know that speed of light, c is equal to speed of light. What's the value of that? What is the value of that? C is equal to speed of light 3 into 10 power 8. 3 into 10 power 8 meter per second. 3 into 10 power 8 meter per second. Okay. Now, okay, here the relation between the speed of light in vacuum, c is equal to, I am taking it as nu lambda. C is equal to nu lambda. Relation between the frequency, wavelength and speed of light. C is equal to nu lambda. Here lambda is equal to wavelength of radiation. Wavelength of radiation. Okay, and now substitute in the place of nu is equal to, what's the value? Nu is equal to c by lambda. Substitute this nu equal to c by lambda in this equation. E is equal to h nu. E is equal to h nu. Then you will get it as E is equal to h in the place of nu. In the place of nu, I am taking it as c by lambda. E is equal to hc by lambda. This is another formula. If you substitute h value and c value, then it is h is a constant, c also a constant, and thereby here you will get this value is in the form of 12,400 by lambda. Then this energy of the photon is represented in the form of electron volt. What is this? Electron volt. Generally it is in joules, but here I represent it as electron volt. How come you convert electron volt into joules? 1 electron volt is equal to 1 electron volt is equal to 1.6 into 10 power minus 19 joules. 1 electron volt is equal to 1.6 into 10 power minus 19 joules. Okay, and now here we are taking next one. This is very important formula. Remember this, E is equal to hc by lambda, 12,400 by lambda electron volts. At the time of teaching itself, if you recollect the formulae, then it is easy to recapture the content. That is very important for reading the physics or calculating some numericals in physics. Okay, so at the time of teaching itself, we have to take the concepts to your brain. Okay, take this as important point. Okay, and now, so at first here I considered E is equal to h nu. E is equal to h nu and E is equal to hc by lambda. hc by lambda. Okay, and that is equal to 12,400 by lambda electron volts, and then 1 electron volt is equal to 1.6 into 10 power minus 19 joules. For example, if you want to convert joules into electron volts, 1 joule is equal to 1 by 1.6 into 10 power minus 19 electron volts. Okay, then another important formula here, as C is equal to nu lambda. This is another important formula. Okay, C is equal to nu lambda. Here nu is the frequency of radiation, lambda is the wavelength of light or wavelength of radiation, and C is the speed of the light. Okay, and then with this, here I am taking one important concept, and that is photoelectric effect. What is that? Photoelectric effect. What is the photoelectric effect? And that is, this is the metal plate. This is one metal plate. One radiation having frequency, some frequency incident on the metal plate. The frequency of radiation is nu. Okay. When the radiation incident onto the metal plate, what's the metal plate consisting of? The metal plate consisting of free electrons. The metal plate consisting of free electrons. Okay, so the free electrons are present. Generally, the electrons are present, whatever we consider, and those are in outermost orbits. So in the outermost orbit, electrons are present, and those electrons are very loosely bound by the nucleus. And thereby what happens? When the energy of the photon incident onto the metal plate, nothing but incident onto the outermost orbit, then the electrons which are present in the outermost orbit can absorb the energy and comes out from the metal plate. This phenomenon is known as photoelectric effect. Very simple. The energy of the photon absorbed by the electron in the valency orbit, and thereby the electron comes out from the metal plate. This phenomenon is known as photoelectric effect. Got it? No difficulty. Very simple. And now, to this phenomenon, we are taking a mathematical equation. So here at first I said that the energy of the photon is absorbed by the electron, and thereby it comes out. For the coming out of the electron, some of the energy of the photon can be utilized. That energy is known as work function. And remaining energy is imparted as kinetic energy. For example, the energy of the photon is E is equal to 10 joules. In the 10 joules, 2 joules of energy is utilized to come out from the metal plate. How much remaining energy? The remaining energy is 8 joules. This 8 joules of energy is imparted as kinetic energy of the photoelectrons. Once again I am saying, what is the total energy of the photon? 10 joules. In that, how much energy is utilized to come out from the metal plate? 2 joules. What about the remaining energy? 8 joules. Okay, so here this 2 joules and 8 joules, 2 joules of energy is taken as work function. 8 joules of energy is taken as kinetic energy. Okay, and this is one of the important formula once again. Then what about phi naught? Phi naught is called work function. Got it? Work function. Ke represents kinetic energy. Ke represents kinetic energy. Phi naught represents work function. Ke represents kinetic energy. Okay, done. And now here I am taking further. Now work function. Work function is equal to phi naught is equal to work function phi naught is equal to h nu naught. H nu naught. What is the nu naught? Nu naught is the threshold frequency of the metal plate. Threshold frequency. What is the meaning of threshold frequency? Threshold frequency is nothing but it is the minimum frequency. Minimum frequency for which the photoelectric emission takes place. It means what? This, if the radiation consisting of at least nu naught frequency, then only the photoelectric process can be considered. Electron can be ejected. If the frequency of the radiation is less than nu naught, nothing but less than threshold frequency, then there is no concept of photoelectric effect. There is no concept of photoelectric effect. Okay, so here what I am taking, nu naught is the threshold frequency. What is the meaning of threshold frequency? That is the minimum frequency. Minimum frequency for which the photoelectric effect takes place, then that is known as threshold frequency. If the frequency of radiation is less than nu naught, less than this value, then there is no concept of photoelectric effect. Are you getting? Okay. And now, so phi naught is equal to what's the value? H nu naught. Okay. Now I am taking another formula for this. E is equal to H nu, that is equal to, in the place of phi naught, what I am taking here? H nu naught. What I am taking here? H nu naught. So H nu naught plus Ke, kinetic energy. Now Ke equal to kinetic energy equal to H nu. Take this H nu naught to this side, minus H nu naught. Then kinetic energy is equal to H into nu minus nu naught. This is one formula. Again, kinetic energy is equal to H into nu minus nu naught. Okay, just take a look on this. Okay, and again this also. Fine. And now so in this again I am taking further one. Once I considered the kinetic energy, as you know that kinetic energy is equal to half mv square. Kinetic energy is equal to half mv square. Okay, now H nu is equal to H nu naught plus Ke. Ke is nothing but what? Half mv square. Now with that half mv square is equal to H nu minus H nu naught. Now v square is equal to, H is common, nu minus nu naught, take the 2 as cross multiplication by m. Then v is equal to root over 2h into nu minus nu naught by m. This is the velocity of a photo electron. velocity of photo electron. Okay, next point. Once we consider the kinetic energy, as you know that in the lesson electric potential, electrostatic potential and capacitance, we have the formula of electric potential. Is equal to V is equal to W by Q. V is equal to W by Q. Recollect this formula. V is equal to W by Q. Now W is equal to cross multiplication VQ. And now this work itself is called as kinetic energy. If you are using one electron, according to charge quantization, Q is equal to Ne. For one electron, N is equal to 1, then Q is equal to EV. If you increase the negative potential, what happens? And this is the cathode and this is the anode. From the cathode, electrons are released. When the radiation incident onto the cathode, then electrons are released. These electrons can be attracted by the anode. Why? Because this cathode is at a negative potential, and this anode is at a positive potential. Okay, so thereby here what happens? When you increase the negative potential or decrease the positive potential, and thereby what happens? The electron reached to the anode gradually decreases. When the electrons reach to the anode, nothing but the anode, less number of electrons are reached. So this process nothing but, if again you increase the negative potential, or decrease the positive potential, then what happens here? Gradually the number of electrons reached to the anode gradually decreases. At one particular potential, no photoelectrons are reached to the anode. No photoelectrons are reached to the anode. And thereby what happens here? That potential is known as stopping potential. V0. So the formula I am taking it as KE is equal to EV0. Okay, and this is another formula. Kinetic energy is equal to EV0. Now substitute again in the photoelectric equation. What is the photoelectric equation? H nu is equal to phi naught plus KE. Again H nu is equal to phi naught H nu naught plus KE EV0. Now EV0 is equal to H nu minus H nu naught. Then V0 is equal to H into nu minus nu naught by E. This is another formula. Okay, and now as you know that same formula once again I am taking here. H nu is equal to H nu naught plus what's that? KE. H nu nothing but Hc by lambda. H nu naught Hc by lambda naught plus KE. KE is equal to Hc into 1 by lambda. If you take this one to this side, minus it becomes Hc common in both. So 1 by lambda then minus 1 by lambda naught. This is another formula. What is the lambda naught? Lambda naught is called threshold wavelength. What is the meaning of threshold wavelength? It is the maximum wavelength for the radiation for which photoelectric effect takes place. Nu naught represents the threshold frequency. Threshold frequency. This is minimum frequency. If the frequency is minimum, this is the minimum frequency. If the frequency is minimum, wavelength is maximum. Threshold wavelength. Threshold wavelength. This is a threshold frequency, threshold wavelength. Try to remember. And with this maximum number of, with this content, maximum number of numericals can be continue, and we will get the success. And these formulae are very important, mainly the photoelectric equation, okay. Very simple content, very easy to remember, and very easy to get the score, okay. And now here I am taking further. Based on this, I will do some numericals, and thereby you will get easy understanding, right? See this question. Okay. If the wavelength of radiation is 4000 Armstrong units, then the energy of the photon is. Once again I am reading. If the wavelength of the radiation is 4000 Armstrong units, then the energy of the photon is. Okay. So here I am taking that energy of the photon. We need to calculate the energy of the photon. E is equal to question mark. And then what's the value given in the problem? Lambda. Lambda is mentioned in 4000 Armstrong units. 1 Armstrong unit is equal to 10 power minus 10 meters. Wherever it can be essential, use this. 1 Armstrong unit is equal to 10 power minus 10 meters. 1 Armstrong unit is equal to 10 power minus 10 meters. Okay. And now, so what's the formula? I said to you one formula. E is equal to 12,400 by lambda. Lambda must be in Armstrong units here. If you want to represent in electron volts, lambda must be in Armstrong units. Then E is equal to 12,400 by lambda is 4,000, and thereby you will get the value as 3.1 electron volt. Okay. Then another formula. Second question I am taking. This is also one more model. A monochromatic source of light operating at 200 watt. A monochromatic source of light operating at 200 watt. Watt is the unit of power, so power is mentioned in the problem. 200 watt emits 4 into 10 power 20 photons per second. Number of photons, see here, number of photons per second. I think but n by t is mentioned. Number of photons per second, n by t. N represents number of photons, t represents time, that is in seconds. What's the value? 4 into 10 power 20. 4 into 10 power 20 mentioned in the problem. Then what we need to calculate to find the wavelength? Lambda is equal to question mark. Find the wavelength. So for this, as you know that E is equal to h nu that is equal to hc by lambda. hc by lambda. Why? Because we need to calculate the lambda value, wavelength value. Okay, so now power is mentioned 200 watt. 200 watt. So generally, what is the formula of power? Power is equal to work by time. Power is equal to work by time. Okay, and then with this, work is nothing but energy. Here energy is nothing but energy of photon by time. Then P represents power. Energy of photon h nu by time is t. Time is t. Okay, so now here once again I am taking that is equal to for one photon this is the power. For n photons n into for n photons n into, and that's why n into hc by lambda t. H nu replace with hc by lambda in the denominator as same as t, time. Now P is equal to n by t, separate this, n by t, and hc by lambda. hc by lambda. Okay, and now with that here we are taking further. What's that? Lambda we used to consider. Lambda is equal to n by t into hc by p. hc by p. Okay, and now substitute the values. Lambda equal to n by t. What is the n by t? Number of photons per second. Number of photons per second. What is the value? 4 into 10 power 20. H 6.62 into 10 power minus 34 into what's the value of C? 3 into 10 power 8 by P. Power is mentioned in, what is the power? 200 watts. 200 watts. Okay. Like this we can calculate that value. Then that value is 3972 Armstrong units. Like this we can do the numerical. And then another numerical. And another numerical is you can do the numerical from NEET 2018. At first I am taking the numerical. Just read out this. When the light of frequency 2 nu naught, this is 2 nu naught. Just wait. Yeah. When the light of frequency 2 nu naught, so frequency of radiation is given 2 nu naught, where nu naught is the threshold frequency on a metal plate. The maximum velocity of the electrons emitted is V1. When the frequency of the incident radiation is increased to 5 nu naught, the maximum velocity of electrons emitted from the same plate is V2. The ratio of V1 to V2 is, when the light of frequency 2 nu naught, so this is in 2018 question. in 2018 NEET, this question asked, right? So I'm explaining this question. Just take out this. When the light of frequency 2 nu naught, nu1 is equal to 2 nu naught, where where nu naught is the threshold frequency. Okay, the maximum velocity of electrons emitted is v1. So maximum velocity, so here in the first case, this is, I am taking it as case 1. In case 1, the frequency of radiation is 2 nu naught and velocity of photoelectrons is equal to v1, velocity of photoelectrons. Okay, and now what is that next one? When the frequency of incident radiation is increased to 5 nu naught. So now in the second case, what happens? In the second case, the frequency is increased to 5 nu naught. The second case, the frequency is increased to 5 nu naught. Then what happens? See here. The maximum velocity of electrons emitted from the same plate is v2. Now in this case, velocity of photoelectrons is v2. And what is the question in this? The question is the ratio of v1 to v2 is the ratio of v1 to v2. So we need to calculate v1 by v2 is equal to question mark. And very simple. In the first case, what they mentioned? In the first case, nu1, threshold frequency of the radiation is mentioned, 2 nu naught, and maximum velocity is v1. In the second case, the frequency of radiation is 5 nu naught. Frequency of radiation is 5 nu naught, and then what is the velocity? v2. The ratio of v1 to v2 we need to calculate. Okay, done. So I am doing the problem. While doing the problem, you need to take any problem that is. At first, after reading the problem, you have to analyze some factors. The first factor is that problem belongs to which lesson? First topic, you need to recollect topic name, that is lesson name. After that, subtopic, in that lesson which part it belongs to, that you need to recollect. Subtopic. After recollecting the subtopic, you need to analyze or recollect all the formulae in that lesson. From that formulae, you need to pick the relevant formula for this problem. Relevant formula. Next one. After taking the relevant formula, then what are the given contents in the problem which we need to calculate? In that form, we need to change the formula. We need to change the formula. Okay, then next one. After that, whether the values in the problem all are in same method or in some other method. Nothing but all the values should be either in SI method or CGS method. If some values are not in a proper way, then you need to convert all should be in SI or all should be in CGS. So all values should be either in SI or CGS. Then afterwards, we need to substitute the values in the formula. So be careful if the powers are present, and those powers you need to calculate with very conscious, right? And then afterwards, calculation. This calculation you will get by practice. And the next one is answer. So our given answer may or may not present in options. In physics, that is the problem, may or may not. For example, if the given answer is in meters, but we will get in Armstrong units. The Armstrong unit should be converted into meters. Otherwise, the given answer, if you our answer is 10 power minus 3 we got, but the options consisting of 10 power minus 4 into 10 power minus 4. So we need to convert 10 power minus 3 into 10 power minus 4. After that we can check the relevant option and we have to choose that particular option. So need to convert the option if essential. If essential, right? All these are the important points you need to remember at the time of doing the numerical. Okay, and now come to the problem. And here what is the this is the topic related to the dual nature of radiation matter, and subtopic is nothing but Einstein photoelectric effect. The relevant formula here I am taking it as E is equal to phi naught plus half mv square. E is equal to phi naught plus half mv square. At first case 1 I am taking case 1. So in case of case 1 here E is nothing but h nu, h into nu. What is the nu? Nu 1 in the first case. Here we are taking it as nu 1. So nu 1, what is the nu 1 value? 2 nu naught plus is equal to, so what is the phi naught? Phi naught is equal to h nu naught plus half m. In the problem given that velocity of the photoelectrons in the first case is v1. In the first case is v1, and then with this take this h nu naught to this side, that is minus h nu naught. H common, 2 nu naught minus nu naught is equal to half m v1 square. Then that is equal to h nu naught, 2 minus 1, 1, half m v1 square. This is equation 1. Okay, and then come across the further h into, second case this is h into, what is the frequency? Frequency in the second case is phi nu naught. Okay, is equal to phi naught, no change in this, h nu naught plus half m v2 square. Okay, and now here take this h nu naught to this side, then h into phi nu naught minus nu naught, that is equal to half m v2 square. H into 4 nu naught is equal to half m v2 square. This is equation 2. Now I am taking 1 by 2. 1 is h nu naught, 2 is 4h nu naught. Here itself h into 4 nu naught, 4h nu naught is equal to what is that here? Half mv1 square. What is that? Half mv1 square. And what is here? Half mv2 square. Now h nu naught get cancelled, half m get cancelled. v1 square by v2 square is equal to 1 by 4. Then v1 by v2 is equal to, what's the value? 1 by 2. This is the answer. What is the ratio? And that is v1 by v2 is equal to 1 by 2. Okay, and then in 2021, one question is asked. Just take a look on this question. The number of photons per second on an average emitted by the source on an average emitted by the source of monochromatic light of wavelength 600 nanometer when it delivers, the power of 3.3 into 10 power minus 3 watt will be. Okay, just read out the question once again. Just read out the question once again. And this is the question in 2021 NEET. 2021. Okay. Okay. Now, the number of photons per second. So we need to calculate number of photons per second, n by t. We need to calculate n by t. Are you getting? N by t. Okay. And here, what is the another value is given? The source of monochromatic light of wavelength 600 nanometer. Lambda is mentioned. 600 nanometer. Nano represents 10 power minus 9. Nano represents 10 power minus 9. Okay. And then another thing, when it delivers the power of 3.3 into 10 power minus 3 watt, power is given 3.3 into 10 power minus 3 watt. And H value given in the problem, already I said to you, in the board exam, nothing but in the NEET exam, the constant should be present in the brackets of given problem, right? H is equal to 6.6 into 10 power minus 34 joule second. These are the values given in the problem. We need to calculate n by t. Already we have seen the formula for this. Power is equal to NHC by lambda t. Power is equal to NHC by lambda t. Then power is equal to n by t into hc by lambda. We need to calculate n by t. N by t is equal to cross multiplication, p into lambda by hc. This lambda goes to this side and hc taken to this side, p lambda by hc. Then after substituting all the values, p value, h value and lambda value, and c is equal to 3 into 10 power 8 meter per second. If the value is not given, you need to recollect from your mind, right? C is equal to 3 into 10 power 8 meter per second. Okay, now after substituting all these values, p value, lambda value, h value and c value, then you will get a 10 power 16 number of photoelectrons per second. 10 power 16 photoelectrons per second.